Hey, this is Sean Murphy of SK Murphy. I'm the MC for today's Lean Culture webinar on 10 best practices for agile product hardware realization. We're fortunate today to have Michael Keer, who's the founder and managing partner of the Product Realization Group. He brings over 30 years of experience with high-tech electronic markets, their development and their introduction into market. Mike received a BS in Industrial Engineering and Master's in Manufacturing Engineering from Northwestern University in Evanston, Illinois. Mike?
Thank you, Sean. Appreciate the time. Glad to be here. And today I'm going to talk about hardware product realization and some of the practices that you can use to optimize that process. Start a little bit with Product Realization Group, which I started back in 2010 for after seeing a lot of companies struggle with what does it take to get a physical product from the laboratory to full-scale manufacturing. And we really help companies navigate that, what I call the new product development and introduction process. And since COVID, we've been mission driven, really trying to focus on companies that are having a positive impact on the planet. So with that, I'm going to share over 30 years of my expertise, as well as expertise that I've gleaned from the group around the hardware product realization process. And let's start with the industry challenge. This graph really illustrates it well, what a lot of companies do, especially if you look at earlier stage tech companies, kind of Silicon Valley type companies. They often start lean. They have founders that don't have a lot of experience, but they're very bright. Maybe spinning out of better universities. They make commitments they often can't meet because they're trying to raise money. And by the time the product actually ships, it's late, it's over budget, and it's not meeting the requirements. So this is kind of a classic challenge that I've seen. And you lose on both sides in this case. You lose on the front end because you get products out later, and you lose on the back end because by not following good design practices, you actually have a shorter profitability life cycle for the product. So that is really where you don't want to be. And I've seen a lot of companies, follow this curve and really not make it very far as businesses. And then you say, well, why is it so complicated? And it's so complicated because you've got a lot of different disciplines when you're talking about hardware, especially, let's say relative to software, which primarily is software programmers. You've got a lot of different disciplines and expertise that needs to be brought to bear, and all of that needs to be brought to bear at high levels. So that's kind of the people side of it. And then in addition, you've got the process and the schedule side of it, where these resources not only have to be capable, but they also have to be integrated in the right way. Think about a general contractor building a house, right? You've got to lay the foundation before you put the plumbing in and the drywall and everything else. And it's the same thing for a physical product, right? You have to sequence things in a proper way and do the right things early in order to make sure you have a good product going out. And the combination of those two elements, in my experience, it makes it extremely challenging for hardware businesses. And if you are a hardware company and you're wondering, what you should be concerned about, these are some of the classic, what I would call warning signs that hardware companies have. Anything from, hey, your schedule's slipping, or you're adding too many features, you're burning too much cash, you're relying on tribal knowledge, these kind of things. But any one of these things, I would say, would be a warning sign and should be an indicator that you should be taking some mitigating steps to modify your process.
Mike, could you explain a little bit about what you mean by tribal knowledge as a warning sign?
Yeah, well, tribal knowledge, early on can be okay, but if you're talking about actually scaling a product, the fact that you're relying on tribal knowledge is quite risky. Tribal knowledge essentially is where a lot of knowledge is in an engineer's head, or one particular individual's head, or a department. And the risk is, if somebody leaves the business, all that tribal knowledge is going to go with them, and then what is it? How do you maintain and leverage the knowledge that they've been using, right? So the idea of good practices and good processes is you can take that tribal knowledge, put it in a system like a PLM system or ERP system, or some kind of a business system that's going to capture that, and then if people come and go, it's not as impactful to the business, not as risky to the business. Does that answer the question?
No, thank you.
Yeah, you bet. Okay, so the good news is over the last 30 years, we spent a lot of a lot of time focused in this area of what does it take to get a physical product to market, and we've defined these 10 best practices that by following these, you can really positively impact your ability to get products to market. And it really stems from proactive investment, kind of doing the right things early on in the process to get you where you want to go. It does mean investing a little bit more, than some companies want early, but by doing that, you actually save, money overall. You have then the ability to meet your launch dates, get the right product market fit, mitigate the risk of scalability, lower your costs, and develop resilient supply chains. And the benefits are really quite fast. You get more profit early, so because you get your profit on time, you get you faster to cash. And then by following good design principles, like modular design, DFX, these kind of techniques, you can actually extend the life of the product longer. So you win on the front end and you win on the back end. And before we dive right into the practices, I'm going to talk a little bit about some just high level concepts. And one would be understanding your market. So in these 10 practices, we don't really talk about marketing, but marketing obviously is very important. And when you think about where your products are shipping, it also actually relates to the design of the product. Think about a product that may be shipping into Europe, let's say, versus the US versus China. These might have different electrical standards. So where you're shipping is really critical to how you design your schedules, as well as how you develop your products. Okay, in addition to just understanding, do you have the right product for the market, right? And then the other concept is around cost. And a lot of earlier stage companies I've worked with, and even sometimes bigger companies, they misunderstand cost. They think about cost as material costs or material manufacturing cost. And the analogy I use there is, think about a pile of wood on your lawn. That's not a house, right? That's just a pile of wood on your lawn. So so really understanding what are all the costs that go into the product early, and getting that into a realistic budget and a realistic schedule can go a long way to making sure you have enough financial runway to get your product out to market within the budget specified. But if you don't understand these costs, and you assume kind of material manufacturing cost, you're every time going to underestimate the real cost. You're going to run out of money, and that's never a positive outcome from what I've seen. And then the next concept, and kind of the last high level concept, is what I call cost escalation. And this is really a big difference, I would say, between hardware and software, where in the software world, you can iterate, and you've got these agile principles and practices, and you can kind of iterate forever, right? You change software, and if you have one copy or a million copies and you want to make a change, it's as easy as changing the code, testing the code, and then deploying the code. And that's, from a cost standpoint, that's kind of it. If you talk about hardware and you have product already in the field, the only way to change that product is to get a spare unit out, get a repair person out, or ship the unit back and replace the unit, and then ship another unit out. So the cost on the hardware side, let's say, compared to software, is vast. And that is really kind of teeing off these 10 best practices, and why it's so important to do these things early. By doing the right things early, you can mitigate all these extra costs that you might encounter down the road. Think about recently what's happened with Boeing, where they have defects on the plane. GM had a big recall. Samsung phones burned up. So if you get it wrong, the cost is really vast. And it's not, people don't have a product then either to use. So with that, I'm gonna go into the 10 best practices, starting with agile hardware development, and then working kind of sequentially through the NPI and new product development and introduction process, through getting ready for volume manufacturing. And the assumption that I'm making is that you already understand your market. This is not a marketing presentation. It's really assuming that you understand the market, you understand kind of at a core level what the product is, and you now want to understand what techniques can you apply to better get that product from the laboratory to full scale manufacturing. Okay. And talk a little bit about Agile. People have heard of Agile and software for a long time. It's starting to make its way into the hardware world, which is great. But the caveat that I have when you talk about Agile for hardware is it's really bounded. So the boundary conditions that I recommend is in a high tech company, you're going to want to stop at design freeze, and in a med tech company, you're going to need to stop the agile process when you get full medical device design controls in place. So and you say, well, why? Why can't you keep on spinning forever? Well, a simple example, let's say that you have a product developed and you get into regulatory testing, and you pass FDA or you pass UL or FCC or whatever the regulatory body is. The reality is, if you then change that product, you're going to have to go back through another cycle of testing and fully resubmit. So it's just not simply practical to do that. In addition, you've got to buy material. So if you're spinning product and buying material, now you're going to have to scrap a bunch of material. So early in the design cycle, great, it can be quite helpful. I'll talk about some tools and techniques when we talk about simulation. But as you get further into this development cycle, you really have to shift from Agile back into waterfall as you get into design freeze. Okay. And then when I talk about conceptually, I mean, it's kind of a conceptual model of Agile hardware, I'm really talking about cycles of innovation. So defining requirements, testing requirements through the various phases of prototyping. So starting with feasibility, proto 1, proto 2, on into production launch. And every time you go through these cycles, you're gonna learn things. Let's say you design a part, an integrated circuit, and then you test that part. Well, when you design it in, you're going to constrain your design space, and then when you test it, you're going to close your knowledge gap, and that kind of goes on until you get to the point where you really have a high level of confidence that the product is meeting the specs that you want it to meet and performing the way you want it to perform. The only caveat is, the real world isn't so linear, right? The real world looks a little bit more like this, where you have to be flexible to pivot and put these kind of pivots into the schedule, because they're going to happen. Simple example: a few years back, we did a project with a customer that had an IoT device that was reading a screen, and we thought we could use a photo detector to do the measurement. Turned out when we actually tested it in feasibility, the cover was shaking. Photo detector just wasn't able to get a clear signal, and we had to shift to more of an optical, like a camera sensor, which did change the design. So it was clearly a pivot. It also increased the amount of data because it was an IoT device. Now you got more data going into the cloud. But the good news is, if you do this stuff early and you catch these kind of things, in the feasibility and prototype, one stages, you have the flexibility to pivot, and you can still get the product out to market, per schedule and per budget. Okay, and then a little bit of kind of tools and techniques for when you get into the actual process of now you're in your new product development and introduction cycle. What are some of the critical things you want to do? First, that I always recommend is getting the right people on the bus, getting the right team. I worked with a company a few years back that designed a very innovative zero gravity treadmill, and it was an engineering centric organization, and they designed this treadmill just about a half an inch bigger than the standard door width. So then every time they had to install it, because they didn't have field service, give their inputs, they had to disassemble, reassemble, knock windows out, knock doors out. I mean, it really was quite problematic over time. Whereas if they had that feedback early, if they had the right team, they could have easily just redesigned it a little bit narrower. It was certainly possible to do. So getting the right people, and then going through those cycles of innovation with the team, doing good good design reviews, phase gate reviews, really can help mitigate a lot of risk and identify issues before they become a problem. The other element is the schedule, and I've seen many companies just wildly underestimate the schedule. They forget about regulatory or reliability, or preparing additional prototypes, et cetera. So understanding at a detail level, what does it take to effectively develop this thing? Do you have design reviews covered in terms of the time? Do you have regulatory covered? Do you have reliability in there? Whatever other verification and testing you need. And getting a realistic schedule, getting the right team can go really a long way to putting on that path of, faster profitability, getting better products out to the market. And then the last thing I'll mention is development strategies. And this would be, do you develop in-house? Do you hire outside consultants? Do you engage a contract manufacturer? Do you build in-house? Do you partner with what's called original design and manufacturer, where you kind of turn the design over? And I would say there's no prescription that I can say that this is the right way to do it. What I would say is it really depends on what are your core competencies. So kind of you look at the last bullet, understanding core competencies, and then depending on the product and depending on the business and the volume is going to really dictate what is the right development strategy that you're going to want to deploy.
Mike, when you talk about the fitting in the door, I remember the original Cisco AGS router was 10 1/4 by 19 1/4 by 20 inches. And we discovered that was just a little too big for a 19-inch rack, which was the actual standard.
Yeah, that's another, I think, great point about hardware versus software, right? Software, you can just change code and hit a button. If you design hardware wrong, you got to redesign the whole thing. It just gets to be really problematic. So, yeah. But thank you for that point, Sean.
I have a similar quick short story, if you don't mind. Can you hear me?
Sure.
Please go ahead.
No, it's shelving, right? We're building a automated dog food container that would report, when the dog food is starting to get empty. And we did catch this in time. If it didn't, there's size limits from retail shelving and retail placement or if you want better placement. So redesigned it into 2 parts, so it wasn't as tall. It could be taken apart. It could fit, on the shelf at the right spots in the store. It's another consideration.
Great. Thanks, Tuppy. Okay, so moving on to kind of the best practice number 2: leverage simulation tools, rapid prototyping. This directly supports what we talked about before. When you're talking about leveraging these agile principles early, these are some of the tools and techniques that actually enable that. So simulation, there's a lot of great simulation tools. If I look at where I was, when I started, more than 30 years ago, really wasn't much out there. Additive manufacturing didn't exist. So these tools are really powerful. They do, I would say, to some degree, level the playing field between software and hardware. You can do a lot in simulation where you don't even have to do anything in hardware. You simulate it before you, let's say, bring any hardware to bear. And then additive manufacturing, you can do a lot of simulation with real physical products and put them in front of people and test different designs and so forth. Again, that used to be quite costly and time consuming in order to do. So these are definitely techniques that you should be leveraging if you're not already, and especially early in the development process. And then the next concept is minimum viable product, and this is really important. And there are companies, if you look at products like an iPhone or a Tesla, that are what I would call combination products, and most products are a combination of software and hardware. And the trick here is to have as stable a hardware platform as possible with as least change and as few parts as possible. And then, if it makes sense for your product, do as much change and enough flexibility on the software side. And companies that I've seen kind of leverage that really have just better products and make more money than companies that are kind of designing these very complex physical products that are changing all the time. Now, if you have a very high-tech product that needs that, that's one thing. But where possible, think about what is the minimum viable product that the market wants. Every part adds cost, every part adds time, every part adds risk, right? And every feature the same thing. But if you design these things with the intent of being able to scale them, things like modular design, doesn't mean you can't add functionality and features and complexity over time. It just means when you first go to market, you want the product to be as simple as possible. It's going to minimize your schedule, going to minimize your budget. And then the other thing that is really important is understanding risk. And a lot of technology founders tend to focus on what risks they're comfortable with. Maybe, a few of the ones here: funding, technology development, and then they often miss big ones like market. Well, does anybody want the product? I've talked to a lot of people that say, "Hey, this is so cool. The market, people are going to knock the door down. I don't even have to market it." Well, I haven't seen that work too often. So the recommendation I would have here is really understand all the risks involved in your product. And there's a lot of them, from funding to people to market to technology. And one exercise I've helped companies with is to document what are the different risks associated with the different areas. So what are the funding risks? What are the people risks? What are the market risks? And then map those out with your core team, your MPI team, and then come up with a mitigation strategy and an action plan, and do that all proactively. This should all be done, really early in the development process. And by doing this, you really will go a long way to just not having these risks show up, down the road and surprise you, like the product, nobody wants to buy it, or you can't get funding, or you can't buy parts because your supply chain is messed up. Okay, and the other technique, the kind of maps along with MVP, good practice is what I call design for excellence. And many people are familiar with the term design for manufacturing, and there's a whole bunch of other, kind of good practices that are beyond just manufacturability, right? There's assembly, there's testability, there's cost, there's serviceability. And by applying these techniques in a regimented kind of way, let's say through the phase gate process, if you recall, we talked about those cycles of innovation. At the end of each cycle of innovation, you should be really reviewing what you did, and part of that review should include design for assembly, design for cost, all these DFX kind of things. And companies that successfully do apply these have an easier time to scale. They have better cash management, easier parts availability, and best of all, products, they work better in the field. You end up with happier customer, and they're more reliable. So you have less field returns and less, impact around brand erosion, related to those kind of issues. So that's kind of the high level concept. I'll talk a little bit about now, diving a little bit deeper into what are some practical, tools, techniques, tips that you can use around design for excellence. So the first I would say is, clearly creating a product structure, bill of material, eliminating or minimizing fasteners. As I mentioned earlier, every part is cost, every part is time, every part is risk. Depending on where you are, but if you have multiple products, if you can design and reuse the same part in multiple products, it's going to save you time, it's going to save you money. Definitely second source where it's possible, especially for easy to find components. Apply techniques like poka-yoke, which is, came out of this Toyota manufacturing model. The idea of mistake proofing, think about like a USB cable, it only goes in one way. And as you get products that are going into manufacturing and scaling into higher volume, and I ran production for a number of years, you really don't want items that can be reversed, because in production, trust me, they will be. So, if there's only one way that they can go in, it's going to just make your life a lot easier as you get into higher volumes and, greater scales of products. The other thing, modular design with logical subassemblies. Again, this mix of hardware, software that I see in most products today, the more flexibility you can have on the software side and the more stable your hardware platform is, the happier you're going to be, as a manufacturing company, right? And I would also argue the happier your customers are going to be, right? And then the other element is testability. So, simple example, I worked, my second startup was very, kind of leanly funded, and design wanted to save a little bit of budget and a little bit of time, a couple of days in the schedule. So they didn't put what are called in-circuit test points. These are just kind of simple test points on the bottom of the board that allow you to do a 30-second test instead of a longer functional test. So that happened, and I kind of fought the battle. I lost the battle, and for the next 3 years, I had to do a 15-minute functional test on this product, and it cost the company well over $1 million just in test time. Not to mention it was just harder to debug, right? Because without these test points and the in-circuit test, now you don't know what's going on, right? You got to spend more time debugging the product. So again, easy to do early. Maybe it takes a few more days, but well worth the time and well worth the investment if you're getting into any kind of real volume. Okay, and then the other thing is reliability, validation test. You want to start as early as possible. This follows the whole theme that I've been, talking about, which is proactive investment and doing things early so that you can avoid the pain later. And I would say this starts really with good product requirements. So defining good product requirements then can be validated with good reliability programs and good validation and test models. I've listed a very few things. I mean, there's a lot to product reliability. There's a lot to validation tests, but things like calculating mean time between failures at the component level, utilizing tools like failure mode and effect analysis to understand what are the risks and how do you mitigate the risk. Leveraging generally outside labs for things like highly accelerated life testing, highly accelerated screen testing. All these things can really go a long way to making sure that when you're shipping a hardware product, you've got it nailed down, it's reliable, and you're not going to have field problems down the road. Obviously, this is going to vary quite a bit between products and industries, right? So you have to understand what is the reliability you need. If you're shipping a product to space, you better have redundancy and you better have products that aren't going to fail. If you're shipping a product that's a drone that's going to explode, in the field, maybe not as critical, right? One-time use sort of a thing. So that's really going to depend on the product and the application. But understanding that early and then mapping that out and making sure you have a good, kind of model and paradigm to support it is the takeaway here. And that leads into regulatory compliance. I mentioned this earlier. One of my earlier companies, actually the first company I came to Silicon Valley, very high profile, well-funded optical telecom company, had a really innovative idea for bending a fiber. So instead of breaking a fiber invasively, you could just bend it and then read the signal on and off. And they came up with this aha idea of, hey, let's create a neighborhood connectivity without having to break the fiber. They called it a loop, fiber to loop. And they spent $300 million, developing the product. What they forgot to do was ask the regulatory body if it was a valid architecture. So 3 years into it, over 300 million, they finally went to Belcor and said, hey, is this valid? And Belcor came back and said, nope, it's not valid. You have to redesign the whole product. So long story short, another 3 years, 300 million, they redesigned it. And at that point, they had missed the window on the market. So so these things are really important. There's other examples. Think Theranos, 23andMe. I mean, all you poo-pooed the FDA. Look how that worked out. So my experience is if you understand early what's needed, it's not that difficult to actually comply with these things. It's the companies that ignore it and then try and shoehorn these things in or poo-poo the agencies really that can get into catastrophic troubles. The other recommendation I would say is getting experts to do what I would call a pre-check before you actually go to the agency can really go a long way to help you make sure that you're going to pass before you submit. I would say what you don't want to do is just wing it and then submit and then fail and then have to resubmit again. And I've supported projects like that, and that can easily delay your schedule 3 to 6 months, because you have to go through a whole redesign cycle and then resubmit. So again, proactive investment, understanding what these regs are, getting expertise to do evaluations before you submit, and you'll find it's actually not that difficult to get these things done. So okay, the next one, number 8, and if you notice the first 7 practices really are what I would call product focus. So what do you need to do on the product side and the regulatory side, and how do you get a product out? And then this is really more the process side of it. So I would say there's 2 elements to successful business. One is getting products out that are working right and that the market likes. The other is really being able to scale your business, right? As you add more products, more product lines, let's say you acquire companies, you want to have the right business infrastructure and the right business process so that you can effectively and smoothly scale your business. And this is another area where I see a lot of companies often just do things ad hoc. They'll put in an engineering, development system, and then down the road they'll get a PLM or ERP. And by the time I talk to them, they've got their manual entering the same part number in 3 different systems. Nothing's talking to anything. They're building the wrong product at the manufacturer. They've got a whole bunch of excess and obsolete material. So, again, getting these systems wrong, getting these processes wrong can have a huge impact and can really be an impediment to scaling your business, right? I mean, if you want to really scale and scale smoothly, putting thought into these things early, understanding how the data flows, and mapping all that before you really scale the business can just go a really long way to making it easier not just to bring a successful product to market, but really to scale your business successfully with multiple products. So understand the linkages, understand the data flows, and create a mapping and a strategy early. And you say, well, what does that look like in terms of how the data does flow? This is kind of a generic example of where data gets created generally, somewhere in the CAD world, the customer relationship management world. And then you'll notice a lot of those arrows point into the PLM QMS side of it, because those are generally where your data is stored and your product record is stored. And then that's going to feed into an ERP and then get communicated to your manufacturer. And this applies whether you're manufacturing in-house or whether you're manufacturing at a outside manufacturing company. The data is still going to need to flow around. And then the other element aside from mapping these is understanding how does that data wrap around to improve your overall product and process. So how do you understand what's failing? Let's say in your manufacturing execution system. And then how do you get that data back to engineering so they can effectively design and improve the next generation of product? Okay. And then moving, continuing kind of down the path to supply chain. This is an area that just has changed dramatically. Again, the last 10, 20, 30 years. If you think about environmental catastrophes and geopolitical risk and tariffs and all these things, COVID that have happened in even the last 5 years, it's really quite stunning. So understanding the supply chain and developing a resilient supply chain is really critical these days for companies to be successful. The takeaway on this slide is really how early material costs are locked into the product design, right? I mean, you're talking concept and prototyping. And, because of that, getting people that are really experts in supply chain, experts in materials, understanding what materials are going into the product, or, early before they're locked in is again going to go a long way to giving you a better product that's going to last longer in the field, that's not going to have as many issues. Be at a better price point. During COVID, I had a company that designed in a part, not intentionally, obviously, but it ended up being over a 12-month lead time. Somewhat due to COVID, somewhat due to probably their own design miscalculation, and they ran out of money to start a company, delayed their schedule a year. Can't do that. So these are big issues, right? All of these things, understanding them, what the impact is, and then really taking action to mitigate these things early is where you want to be, and then you'll be able to follow that second curve that I showed, related to the 10 best practices. And then a little bit more advice on so if you want to develop a resilient supply chain, what are some tools, what are some techniques? Things like understanding end market locations, capabilities, tariffs, politics, environment. I mean, all these things are really important. Make sure that you do what I call right size. If you are going to select a contract manufacturer or ODM, make sure that they're sized properly for your business. I've seen a lot of smaller companies try and leverage their way into like a Flex or a Foxconn because they got the big name, and that never works because it's not the right size for the business. And same goes true of a large company trying to use a tier 2 or tier 3 supplier. You got to have the right fit for your business and for your product. One advice would be think about companies that are building products that are similar to your product, and that's probably a good place to look to find good manufacturing partners. The other thing, having been in a manufacturer on the other side of it, the companies I found that I worked best with were the ones that really treated me like an extension of their business, not just like a vendor. So, so you want to, somebody manufacturing your product really is part of your business. They're taking parts that you have specified and they're putting them together. And the more attention you pay and the better you treat those vendors, not only are you going to get better service and get better products, but when things do go awry, let's say with COVID, they're gonna provide you better service. And when things are in scarcity, you're going to want to be the company at the top of the chain, that they want to work with, versus somebody that maybe has not treated them well and now they're not going to get parts. So okay, and then the last point is kind of summing it all up. Making sure that everything that you need is really ready. Have you done all your DFX reviews all the way through? Have you done proper phase gate reviews, DFM? have you got your tooling in place? You know, when you get into volume, generally you're going to want hard tooling versus soft tooling versus 3D printing. You know, rapid prototyping can be very effective early, but when you get into volume production, you know, the game really does change, and you want to get hard tooling, which takes time and money, and you gotta have a stable design for that as well, right? Test plans, regulatory certification. I mean, all the things that we talked about before. And then, you know, making sure that whatever lessons you've learned have been incorporated, and then you're taking that to scale. And you know, kind of the last thing. So in addition to proactive investment, which I kind of hounded on, I would also say think of it as iterative process, especially when you talk about the business systems. You know, you want to be getting better as a business. You know, every step of the way, every product you design, you want to learn and you want to improve. And by doing that, you have a much better chance of following that second curve and making commercialization a competitive advantage instead of something that's going to hurt your business. And I'll end it with, if you want to learn more, last year I published a book called Agile Hardware Product Realization. It goes into a lot more detail than I just talked about here. And it's available on Amazon. So if you're interested in kind of a much deeper dive, scan the QR code, you feel free to get that. And with that, I'll move on to Q&A, and happy to answer any questions anybody has.
The thing that struck me, Mike, is that most of the entrepreneurs I talk to, they're focused on getting the design to work, getting the prototype to work on the bench, and you're bringing up a lot of things that are not necessarily top of mind. What are the most common mistakes you see folks make that are very much focused on, look, I've got it working in the lab, now we're good to go, right? Is there when they come to the PRG, what is the most common kind of thing that you say, hey guys, you forgot about X?
Yeah, that's a great question. I mean, if I come to a company that is interested in our help, I would say the first step there is they know enough to know what they don't know, which is really important, because if you know, and I have heard startup founders say, how hard can it be, and I can figure it all out. And you know, again, the analogy I would use is if you were a first-time homeowner and you had a plot of land and you wanted to build a house the way you wanted it to be, could you design it and buy all the parts and put it all together the first time, having never done it before, and expect it to come out the way you want it, the way you want it to look? And I would say, having done a couple add-ons, absolutely not. And it's the same thing with a hardware product, right? I mean, if you have no experience in developing a hardware product, and you look at all the different disciplines that are required and how they need to be sequenced, and you expect it to come out, right the first time, if you've never done it before, it's not going to happen. Yeah.
We had a request from Sarah. Can you talk about iteration cycles in product design? Sarah, can you provide some context?
Yeah, I'm not
that?
sure. I certainly can. I'm not sure the context, so maybe give a little bit more
Sarah,
information.
can you add a little context on that? You want to unmute maybe and just ask the question more directly? Oh, sorry, Sarah. I apologize. I misread your name.
Sarath, maybe. Yeah.
Sarath.
Yeah.
Hi. So my question is basically about IoT devices manufacturing. So let's see, as technology changes day to day, how we are going to incorporate them as the product iteration changes. Like, is there any methodology you guys follow?
Well, I think that let me make sure I understand the question. Is the question, how do you make sure that you're incorporating the latest and greatest technology into your product?
Correct.
Yeah, I mean, that's really a design question. So I think it's up to the technologists within the business to make sure that whatever the latest technologies are available are being evaluated and and reviewed. So I would balance that, being more on the operations side, right? I don't claim to be a technologist or developer, but what I would say from my perspective is there's leading edge and bleeding edge. I think if you're too far up the technology curve, you often can run into what I would call supply chain issues, where you've got a sole source or single source, And if you want to really scale that product and you've got that, that tends to be a risk, right? So it's really balancing being a cutting edge business and applying the latest and greatest to being so far out on the edge where you actually can't buy parts and you can't do stuff in scale. So that to me is a little bit the trade-off, right? If you get too far along the curve, you risk supply chain issues, cost issues, too much dependence on a single supplier. If you get too far back in the curve, you risk having outdated technology and not being relevant. So it's to me, it's finding the balance. Yeah, if that answers the question.
Yeah, thank you.
Right. Any,
So we had a question from Julia on what do you advise folks to do in terms of best practices for hardware program management? Are there particular KPIs or critical metrics that you'd like to monitor as you go?
It's a great question.
These are good questions.
Yeah, no,
These
that's
are
a really
very
good question. So yeah, there definitely are, you know, metrics. I mean, in terms of keeping the schedule, keeping the budget, you know, making sure key features are part of it. So, you know, I think if I put my program manager hat on, I mean, it's first of all, having a clear schedule defined, having a clear product spec defined, having clear requirements defined. It's really hard to manage something that's mushy. So I think, you know, it all starts, I would start earlier and say, do you have clear requirements? Do you have specs? Do you have validation plans? And then do you have a clear schedule? And then within the framework of that, do you have proper controls and gates to make sure you're on track? So design reviews, phase gate reviews, you know, regular status meetings. If you're more in that agile phase, maybe it's a daily meeting or, you know, every other day meeting. So some of that would also depend on where you are in the cycle. I would say earlier in the cycle, you're going to have a lot more, you know, agile kind of practices that you can use. You can use tools like Jira and others for tracking, Microsoft Project. And then later, you know, later you're going to be more likely to be more in the waterfall, you know, sort of a category. So I think it's leveraging what are the best tools for where you are in the process. And then do you have a nice, clearly defined process that you can follow, you know, and leverage to be successful? And it's a mouthful. I mean, that's a pretty broad topic, but does that help, Julia?
Yes, thank you. And are there any particular sort of tools for managing timelines and gates that you have thought have deemed helpful in the past? I know there's, you know, so many.
Yeah, there's
but I'm just
quite a bit. I
wondering.
mean, I would say, yeah, Jira is quite common. Microsoft Project's common. Yeah. So again, that's not so much my direct expertise, but the tools are, at least my understanding is, are pretty common. You know, there's a few. There's Jira. There's Microsoft Project. There's Smart Sheets. You know, etc. So I think it's either what your company is already using. I don't know again what the nature of your business is, but these tools often, especially in development, are already in place. If not, I would say it's just following what are kind of the latest industry best practices for tools to manage these kind of things, and then look at those and leverage them. But that's only part of it. I mean, the tool is important, but I would say even more important is all the things I mentioned around the process, defining a clear product spec, understanding requirements, validation, you know, having a clear defined. The tools are only going to support the process. So it's getting the tool, but also making sure you have a good solid process that the tool can support. Yeah.
Makes sense. Thank you.
And I think it's the case, Mike, right, that even though we're focused on hardware, there's often a significant firmware and system software component to these. So you need tools or scheduling or tracking that can encompass the software side as well, or at least allow them to mate up.
Absolutely. Yeah. Like I said, I can't recall the last company I worked with that didn't have a combination of hardware and software. So you have to be able to support both. And I think companies that are successful really, you know, do balance kind of the tool set to support both and leverage, you know, the whole stack: hardware, software, mechanical, electrical, firmware. I mean, everything. Yeah.
Roger, you had a question?
Yes, interested in the topic of agile and iteration on the hardware side. I come primarily from the software side, and I hear a lot from people about how it's impossible to do agile in hardware. And so I'm curious kind of how you see agile and iteration happening in hardware. On the software side, we sort of strive to make it an end-to-end thing. So it's not just iterating on a design or iterating on the implementation, but trying to do a whole loop where you're revisiting the requirements after doing basically a full development iteration, going back and iterating on the requirements, doing another full development iteration, and lather, rinse, repeat on that. And of course, that does seem a bit more challenging on the hardware side.
Yeah, well, as I mentioned, I think when you're early in feasibility, prototyping, it's definitely doable. I would say the only caveat would be it may not be doable to the same rapid time frame as software. So for example, if you've got to build a printed circuit board, it takes so much time. It's not going to be a week. It's going to be probably 4 weeks, right? So I would say I wouldn't say directly mapping software agile. I would say it's a modified hardware agile where you may have a little bit of different timeline. Whatever makes sense to get a complete iteration or set of development activities completed. And then you can still get teams together, you can still review, you can still, iterate, especially early. And if you look at some of the techniques I talked about, software simulation can be done very quick. Rapid prototyping, 3D printing. I mean, all these things can actually support pretty well early in the design process, agile methodology. Again, once you hit starting to freeze a design, starting to think about regulatory, starting to think about having to have maybe hard tooling done in order to test it, you really can't do it. I mean, that's why when people say you can do agile throughout, not in my experience, and I just don't see it. I think at some level, once you freeze that design and you need to start buying parts and you need to start going through regulatory compliance, at that point, it's really got to be waterfall. I mean, maybe somebody will figure out how to do it otherwise. Having been in manufacturing and bought parts and scrapped a lot of material, I mean, if you're changing parts on the fly, you're going to be throwing a lot of material away. I don't think that's going to work, and you're going to have to resubmit to regulatory bodies, and there's a whole bunch of stuff that hardware needs that is I think not as needed in software. Maybe depending on us, maybe medical device software are different, but most consumer software probably not going to apply, right?
I sort of have a related question, which is with respect to the validation and testing. I saw in your slides mostly sort of stuff that doesn't actually sort of put it in real use case, meaning that the hardware is going to ultimately be used in a real use case. And it seems like again, this is kind of coming from my software perspectives, but it seems like you'd want to include in your testing something that actually sort of exercises the hardware within a real use case.
Yeah, that's a great point. I don't know if I did talk about it so much, but yeah, I would say the typical hardware deployment methodology would involve applying some of the techniques I talked about, really to wring out the design and say, we're going to take this thing till it fails and put better components in and make sure we have the best possible design that we can. In parallel, and this would be, it would be also part of the commercialization process. It's a good point. So maybe add some content there. But in parallel, you would want to actually deploy some of these units in what are called early field trials, right? Where you actually have them sitting at customers, their beta. They've signed some release saying, "Hey, I'm just playing with this. It's not officially shippable product." And then in a typical hardware cycle, that's pretty normal, where you do that early on, get that market feedback. ideally do minor tweaking that's not going to be major. I mean, if you got to do major, but ideally some some relevant feedback that's going to be fed back, and then before you scale into high volume, you incorporate that feedback. So that is part of the normal hardware development. Yeah, I'd say the only difference between that and the software is, once you deploy that hardware, it ain't changing, right? So, whereas, software, you can deploy it and tweak it and keep on going forever. So it's pretty different. Yeah, and that's why I encourage thinking about modular design and as stable a hardware platform as possible, and then still being able to iterate on the software side where you do have that flexibility. Yeah.
Are there cases where you actually, with the modular design, are able to maybe on a customer side and a customer deployment swap out a module, so to speak?
That's a great question. I think the idea of modular design is you wouldn't have to do that. I mean, at some point, if a product gets old enough, you just have to replace the hardware, right? Or it fails and you have to replace the hardware. So that would follow that principle, though, where you have sub-assemblies that could be, let's say you swap a card in, swap a card out, instead of having to replace the whole system. So there is a lot of design technique around that can save companies time and money for sure. Yeah.
Yeah, that's a very good point. I think when you're saying modular, that covers both design practice, assembly practice, and then what's actually a field replaceable unit. Those may all three be disjoint, right?
Exactly.
You might have a logical element that's actually locked inside of an ASIC or an FPGA. And you may do things in the assembly or the manufacturing process that can't be undone in the field, or at least very easily.
Exactly. Yeah. Yeah.
So it's a good question, Roger. It's a complicated. There's multiple interacting hierarchies there.
Yeah, but some of the better designs I've seen, in practice would be, full functionality is on the hardware design, and then feature sets can be turned off or on by software. So you basically building one type of hardware that is stable, and then you can play around with the software to say, I'm going to turn this feature on or that feature on, and know what the customer is doing, right? Instead of having to say every feature they want to add, you've got to now swap out a different piece of hardware. All right. Anything else? Great questions, by the way. These are really, really good.
Yeah.
I think we're approaching the top of the hour. I see it's like 11:58.
No. I'm sorry. Yeah, Mike. I'm sorry. I got sidetracked mentally thinking about, you get into partitioning of functionality between hardware and software, and you may choose to put things in software because they're less stable or they're less known, even though there's maybe performance penalties or other trade-offs. I really like the way you presented this as a way to manage uncertainty and kind of speed learning. Thanks again for a very great briefing. We will make the slides available and the video will be available. Thank you all for attending. This has been very enlightening.
Great. Thanks again for inviting me, Teresa and Sean. Yeah.
Thanks.
Take care, guys.
Bye.
Bye.